hear me? And please alert me if you lose me, because I'm using my mobile internet. So last time we introduced what are PLDs, and we said we have two categories under this. This was combinational PLDs, and the other one was sequential PLDs. So we have already looked at the combination of PLDs. Can somebody give us examples of combination of PLDs? Yes. Somebody, examples of the combination of PLDs. We looked at this last time.
PLA.
And what is that in full?
It's the programmable logic array.
Okay, so we have a PLA. Another one?
Programmable array logic.
Programmable array logic. And another one? PROM. Okay, yeah, thanks. So today we'll be looking now at the sequential PLDs. In third year, you did what is combinational logic and what is sequential logic. What is the difference between combinational and sequential logic? Any difference that you may not know of? Anyone? Yes, who can give us anything that you know that will be a difference between combinational and sequential logic systems in general, not limited to PLDs. Any difference or characteristics of each of these? Esbon, you are with us. Chelangat, John, you are with us. What about Ismail Lennox? So Ismail, what is the difference between combinational and sequential logic? Ochieng, Dalvin, you can assist us?
In sequential, the output depends on the current inputs and previous outputs.
Okay, who is that?
Shabaki.
Okay. Okay, thank you, Shabaki. That is that is correct. So in sequential logic systems, the output the output depends on the current inputs and the previous outputs. So what does that mean, or what is the implication of this? Because for the combinational, it just depends on the current input. It has no, it doesn't take into account the historical data or outputs. Just the current inputs. That is combinational. But now sequential, it also considers what happened in the past. So the implication of that is that there is some form of storing that whatever was the output previously, so that in the current clock cycle, that data can be accessed. So sequential logic then inherently will have some form of memory. Will have some form of a memory unit. So essentially, sequential logic is a combinational logic, but now we have a feedback loop or a feedback path through the memory unit. So if we were to depict that in a diagram, a sequential logic circuit would have something of this nature. Where we have this as our combinational. This is our combinational logic circuit. Whereas this is our memory unit. And for digital systems, the basic memory unit is a flip-flop. So we have inputs and outputs. That is for a combinational logic circuit. Current inputs are the only ones considered for the current output. But now for sequential logic, we are saying we have some past data to also incorporate through a feedback path, through the memory unit. So this now gives us the sequential logic circuit. And of course, so this is our sequential system. And within sequential systems, we can have synchronous and asynchronous sequential logic. So what's the difference between the two, synchronous and asynchronous? When we hear of a synchronous system, what does that indicate? So for synchronous, we have the aspect of a clock. So the output state output state changes in response to an active clock. In response to an active clock transition. Whereas for asynchronous, there is no clocking or no clock. So anyway, that's just a recap of things that you know that you have covered previously. What is sequential? So at least you have an idea of combinational versus sequential logic. So now bring this back to sequential PLD. You know, the same kind of analysis would make sense. That if we have a sequential PLD and we have a combination of PLD, then it means, in a way, we have to introduce some form of memory. So that means sequential logic, sequential PLDs would mean that we have the combination of PLD, combinational PLD, and then now we are introducing some memory unit. And what is this combination of PLD? This is basic gates that will give us the PAL, the PLA, and so forth. And then the memory at the basic level, this will be a flip-flop. Yeah, and essentially, at a high level, that is what is a sequential PLD. So if we are to depict that in the same kind of diagram as that, then we'll have something of this nature. We have inputs, we have outputs, then we have a memory unit and the feedback path. So this will be our combination of PLD. It could be a PAL, it could be a PLA, it could be a pilon. And this is the basic gates, the and or arrays. And then in the feedback path, we have a memory unit, which we are saying will be flip-flops. We have our inputs, we have the outputs. So top level, this is really what a sequential PLD would be built, but of course it is more detailed than this. And the sequential PLDs, we said we have a few examples here. So before we go to the examples, we have the categories. So here we have the two categories where we have the simple PLDs, that is SPLDs. The other category was the high capacity PLDs. And under this, we had under this, we had two major types of the high capacity PLDs. So we have the complex PLDs, that is CPLDs, and we have the field programmable gate arrays, the FPGAs. So this essentially gives us some of the devices that will fall under sequential PLDs, and from this we can comfortably see and say that, you know, as you progress from simple PLDs to the high capacity PLDs, starting with the complex PLDs and then to the FPGAs, there is increase in complexity. Even from the naming itself, you know, it will communicate that. So the FPGAs are at a more complex level, and of course that complexity also kind of makes them highly utilized in different fields, and for us that is what we'll be looking at. So amongst the other devices within sequential PLDs, we'll only concentrate on the field programmable gate arrays. So that is what we'll be covering, FPGAs. Unfortunately, lights are not yet back here. I only have less than 25 minutes of charge. It's more or less a desktop. I will stop sharing this and just bring up a four slide PPT just for us to introduce FPGA. Please let me know when my screen is visible. And whether the transitions are working. Can you see that there's the presentation transition? Okay, thanks. So I'm not really going to delve so much on definition of FPGA and all that. You can check it up. But what I'm going to depict here is just an example of an FPGA. So when you talk of FPGAs, there are two main manufacturers or vendors of the FPGA. One is Xilinx, and this was acquired sometime, I think 2 years back, by AMD. So now you will find it being referred to as AMD Xilinx. So that is one of the major vendors or manufacturers of FPGAs. The other one is there is it's Intel, but Intel was not in the field of FPGAs. It acquired a company in 2015. I'm trying to remember the name of. Yes, just like Xilinx was acquired. Well, I don't know whether it is acquired or merged with AMD. Intel also got into the field of FPGAs around the year 2015 by acquiring a company known as Altera, and now you'll find those Altera FPGAs, they are under Intel. So those are the main vendors or manufacturers of FPGAs. Of course, there are others, but they are of a lower tier than these two. So what I'm presenting here is just an example of one of the many FPGAs within the Xilinx family, a Kintex 7. It doesn't really matter which type, just to see what makes up an FPGA. So this, of course, an FPGA is a chip, and therefore, you will not utilize it without some support or without it being on some form of a board. Just like an MCU, you need some support circuitry, power and communications and all that, and even programming interface and all that, for you to make use of an MCU, a microcontroller. So the same thing with an FPGA. So this is just so we have a board here, and on that board now we have a chip, which is the FPGA, which is for purposes of this presentation. This is a Kintex 7 FPGA. So now, if you are to kind of zoom in into that FPGA now in the fabric, and you are able to visualize what is inside a particular chip through some software, you will get to see this kind of a structure. So this is now the silicon at the silicon level, how things are arranged, and some of the main elements or building blocks of the FPGA are what we are showing here. We have the clock regions, the input-output banks, the clock management tiles, the CMT. We have the configurable logic blocks, that is the CLB. Then we have the block RAMs, DSPs, lookup tables, flip-flops, and so forth. But when we talk of field programmable gate array, the key thing there is programmable. And out of all these elements or building blocks, what makes the FPGA programmable? Out of what we are showing here. Anyone? We have clock regions, input-output banks, CMT, CLB, BRAM, DSP, lookup tables, flip-flops. What makes FPGA programmable? Please, anyone? Even if you are to guess, there are only 6 options here, so you have like 15% chance of being correct.
I will say the CLB.
CLB.
Yes. Yes, I mean, even from the name. So the configurable logic blocks are really what makes the FPGA, be termed as programmable. It means you can configure those logic blocks to implement the circuit that you wish or you want to implement. Remember, when you talk of programmable here, it's not really, the software programming, but this is the hardware programming. So you are able to actually construct a circuit, within that logic block. So, and that now enables you, to kind of build some custom hardware designs that you otherwise wouldn't be able to do. And remember, the FPGAs, if you recall our digital systems family, you remember it is under the ASICs, the application specific ICs. So where under that we have the PLDs all the way to the full custom. So this is now like midway before you can now start actually designing things from scratch. So now, instead of having a device that has these clock regions, input output banks, CLBs and all that, if you have to go full custom, you'll be designing those yourselves. But an FPGA has done the heavy lifting for you and now gives you some space to actually build your own custom hardware. So this is the structure of an FPGA inside. So, and what makes it programmable or configurable is the CLB. Now, if you are to zoom even further, if you are to zoom even further, you can see where those blocks are located. So you can see the input output banks, the CMT, CLB, PRAM, CLB, DSP, CLB, and so forth. But you can see that indeed the CLB is the, has the highest or the biggest area within that silicon layout, because that is what actually where your circuit, your custom circuit will go. The rest are for support. If you need some processing, some computational or mathematical kind of processing, then you have DSP blocks that will help you with that. You don't have to design the DSPs yourself. Same thing, if you need to store some data, maybe after some computation, you do not need to design a RAM memory yourself. That is already there. You can interface to it. But now the CLB, this is what you can configure and make use of the FPGA to design your own circuits. And as such, of course, it has the the biggest silicon area to allow you to design even more complex circuits. And now if you are to zoom even further, you start to see the constituent components of these blocks. So if you zoom further, you now start seeing what actually is inside the configurable logic block. What are the building blocks for that? And this is what you see. So inside the configurable logic block, these are now really the building blocks, and you can see they are more or less things that you have come across. We have the flip-flops, we have the multiplexers, we have the lookup tables, and we have a logic and carry unit. So at the very basic, a configurable logic block will contain those elements, and now you can, through some hardware programming language, these can be wired differently to achieve whatever circuit that you will want to achieve. So basically, that's really the FPGA in a nutshell. So I will exit that presentation, and my laptop is now at 20 minutes. I really hope that's correct, or hopefully the lights come back or power comes back before it goes off. So let me get back to our Word document, and we can make a few notes on what we have seen within the FPGA. So the main building blocks as we have already seen, there is a configurable logic block. That is a CLB. And as a summary, we note that this is the basic logic resource. This is too big. Yeah. So this is the basic logic resource on an FPGA. And it's the main resource. It's the main resource for implementing general purpose combinational and sequential circuits. In other words, that is the main resource that is available for you to implement your custom circuits. So inside the CLB, what do we find there? We have just seen that in that presentation. Inside the CLB are smaller components. Examples of those components, what have we seen? Yes, very quickly, we have already seen. What are the building blocks of? Sorry?
Multiplexers.
Multiplexers. So we have a multiplexers. We are not going to define what are multiplexers. We know what they are. Another one, what is it? What have we seen? Yes?
Lookup table.
So we have lookup tables. That is the looks. So this one we can define what is a lookup table. So this, and we one or another we already saw this in the some of the applications of read-only memory, where we are able to pre-compute some things and store them, and during runtime we just read out the outputs. We don't need to do the full processing. So this is a lookup table is a collection. Is a collection of gates. It's a collection of gates hardwired on the FPGA. And it stores a predefined list of outputs, for every possible combination, for every combination of the inputs, So just as we looked at last time, this will provide a fast way of retrieving an output rather than for example, we looked at the trigonometry, the cosines and the sines and all those, they don't really change if it's the cosine of a particular angle. that is a constant. It will always be true. So instead of always calculating that, you can store the answer, just like we had the mathematical tables, just to look up. You look up in those tables. So same thing, same concept here. So they provide the lookup tables, the LUTs, provide a fast way. They provide a fast way to retrieve. They provide a fast way to retrieve the output. Retrieve the output of a logic operation. Because the results are stored and then they are referenced rather than calculated. They can also be used, lookup tables can also implement. They can also implement memory functionality. They can implement memory functionality and FIFOs, that is fast in, fast out, also a kind of shift registers. So that's enough for what is a lookup table. What is the other building block, or what is the other element that we may find in a configurable logic block?
Logic and carry.
Yes, the carry and the logic unit. Another one?
Flip-flop.
Yeah, so we have carry and logic. Carry and logic. We have flip-flop. And the flip-flop is the smallest storage resource on the FPGA. The other, so apart from configurable logic block, we also have the block RAM. That is the PRAM. And this, even just from the name, this is a type of RAM. Read random access memory is a type. This is a type of RAM that is embedded throughout an FPGA. Is a type of RAM that is embedded throughout an FPGA for data storage. Now, I only have 7 minutes. The type of RAM embedded throughout an FPGA for data storage, and some of its use, or how it can be used. It can be used to one, to transfer data. Transfer data between multiple clock domains. Transfer data between multiple clock domains by using local FIFOs. It can also be used for transferring data transferring data between an FPGA target and a host processor via either direct memory access FIFOs. The other application is that I don't think we will be able to continue. The power is not yet back. So yeah, unfortunately, my machine is losing power, so we'll have to stop there. But please be on the standby at least for the next 10 minutes. If the lights come back, I will be logged in and will also communicate to the class rep. So please, up to 9:10, do not be very far. Or in your case, if possible, you can still be logged in up to 9:10. If I don't come back by 9:10, then you'll know that I don't yet have the power and we can end the session there. So kindly be on the standby up to 9:10.
Yeah.